Hello, everyone. You are listening to the Immersive Medicine Podcast. In today's episode, we meet with Dr. Sam Browd, professor of neurological surgery at University of Washington and attending neurosurgeon at the Seattle Children's Hospital. Tune in and learn more about his perspective on immersive media and digital therapeutics in healthcare. Thank you all for joining us today, listeners and podcast members alike. For those of you joining us for the first time, my name is Cody. I'm a co host, and I'm a music therapist and therapy designer with years of clinical experience using media as medicine and mental health, rehabilitation, and neurologic disorders. With me today, as always, is my co host, Kiki.
Hi, welcome and welcome back. I'm Kiki or Kira, whichever you prefer. I'm a digital arts and media educator with a passion for video games, digital art, and production. Also, here with us is Toby. Do you want to remind the
Yeah.
people who you are?
I'll do my little spiel. I'm Toby. I'm an occupational therapist. I have a background in working with adults with brain injuries, which makes me so excited to have this this episode here today. Also, I spent a couple of years working in pediatrics too as well, combining video games and therapy. And that's my spiel. Now bring it down to Brian. Tell us all about yourself.
Hey, I'm not down. I'm over to your left. I don't know why you
I
did.
keep getting it wrong all the
It
time.
never works.
I think Cody's messing with Barnaby or something.
Not me. It's not me.
I'm Ryan Douglas. I am a co-founder of Deepwell Digital Therapeutics. I am really pumped because I have my co-founder here with me, Sam Browd, and I'm a therapy designer, device designer, and all-around fan of using video games to keep people healthy.
Amazing. Awesome. And we're going to introduce our guests. And today I'm really excited as well with Toby to interview and learn more from our special guest, Sam, who's going to give us an inside perspective on the developments in healthcare and the potentials on the horizon. So, Sam, do you want to go ahead and give us a brief introduction, maybe share a little bit about your experience?
Yeah, sure. Happy to. Very fun to do this with you guys today. So I'm a pediatric neurosurgeon, and my background in training was also doing PhD in functional MRI, looking at motor learning and imagery. So I've been very interested in sort of understanding how the brain works across sort of my entire professional career. Gotten very interested, certainly with the work that Ryan and I have been doing now over the last several years, trying to understand how we can use gaming and media to think about how we can treat disorders of the brain and start to interact with patients in a way that creates opportunities for them to heal, get better, think about new and novel ways that we can deliver therapies that really leverage our intrinsic sensor system. It's been really fun thinking about what this is from a different perspective. Like training and going through medical school, I learned a lot about neuroscience and the human body, and we kind of always learned about how the vision system works or how the auditory system or smell, all these different senses. And it kind of really struck me a while back that what's really happening as we play a game or we're watching a movie or we have some experience is that we're taking this sensor input and our body's creating chemicals out of that, right? Dopamine and serotonin, and it's how we engage with the world. It's been sort of this evolutionary process for millions of years, and we've arrived at this point, and now I think we're starting to understand how these things actually work. There's a dense body of science and literature now that looks at what happens when you play a game, like what happens when you have some type of experience. And I think we're getting very sophisticated and smart now about how to take those type of experiences and craft them in a way that we can get a particular outcome. So I'm super excited about just the general concept of what we've been working on at Deepwell and this idea of immersive medicine and what that means. It's extremely powerful. So excited to talk more about that today.
Amazing. Well, we're so excited to have you here, and we can't wait to start unpacking some of these topics. Let's see. Anybody have a question ready for Sam or anything? I can pull one
Uh,
up, but
I do. I have a
go for it,
question.
Toby.
Because of your like background in neuro, as a neurosurgeon, and obviously also in like rehabilitation when it comes to brain injury, I'm super curious about learning about using immersive experiences during that sweet spot when someone is just starting their like inpatient, rehabilitation process, and how these immersive experiences can like tickle the brain and for kind of like contribute to that like neuroplasticity experience. We're just trying to create new pathways when you're talking about rehabilitation, or when you're talking about when someone's like healing from anything that that goes on in the brain. I want to hear your thoughts on those things.
Yeah, no, that's a spectacular question, Toby. So, when there's a brain injury, we've always looked at this sort of as a rudimentary thing, right? Like you have an injury, you have a stroke, you have something that happens. And usually what we do is we just kind of sit and give it time. And then we kind of see where somebody ends up. And then we go through more traditional, physical therapy and other things to try and get them back. But if you really go to a much more kind of complex level and try and understand what's going on, we know there's sort of an immediate phase and then a longer term phase. And what's happening with the brain is the brain in certain areas, we're not using it after a stroke. And so the brain's, it uses the tissue and the neurons in a way that is in the moment. And so if you're not using it, we've seen in a variety of different studies that things will shift or they go quiet. And the idea is that if you could jump in earlier with physical therapy and other modalities or leverage immersive medicine, that you can keep certain areas of the brain engaged and active and you don't lose them. And the reorganization can happen both in positive and negative ways. So what we think we can do is that early on after these type of injuries, even if somebody can't move their limb, if they can imagine moving it, or we can take them
Yeah.
through other structured pathways to
Like the
keep
mirror
them.
box stuff. Yeah.
Yeah, you can keep them engaged so that that kind of penumbra, the area around the core injury, can stay engaged and it doesn't shift or move. And so it may be that you can accelerate healing or you can accelerate ways that neuroplasticity occurs. There are ways that this happens physically, like something called a constraint-induced therapy is often
Yeah.
used. I'm sure you're familiar with that, Toby, where me
Yeah.
and a stroke patient actually strap down the arm that's functional, and it
Mhm.
forces that person to use the arm that has the stroke symptoms. And what
Yeah.
that does is it accelerates the neuroplasticity because we're all kind of wired to survive and to move and to be able to do these things. But what happens is the brain gets lazy, if you will, right? If you have
Yeah.
a stroke, you kind of neglect and you forget the use of that limb.
Yes.
So there, I think are very, compelling ways of now taking these concepts of immersive medicine, putting people into an environment that, just using stroke as an example, where we can keep those parts of the brain engaged and facilitate not just retention of those activities, but promote neuroplasticity in ways that are harder to do if you wait longer or if we're just doing this through physical engagement with the patient. So it's incredibly
Yeah.
exciting, like the possibility just in that like microcosm we're talking about.
One of the
Yeah.
games that we talked about early on was this idea that we would put you in a mech suit, right? And that right,
Gundam. Gundam
yeah,
Yeah.
hero.
right, sort of a virtual mech suit, and we'd start doing things like shooting stuff at you, and your shield hand ends up being the hand that or the arm that has potentially been impacted by stroke. And what you can
Right.
do as a therapist
Mm.
then is you can dial how much actual deflection means big deflection as far as the mech is
Range of
concerned.
motion. Yeah.
Exactly giving someone the idea that this is this, and then session at a time Now it takes 10% deflection to get 80% of the mech. Then I want it 20% get to 80% of the mech, and kind of pushing people through, giving them this time to to reutilize that limb. And also because what they're visualizing at that point, they're not visualizing what they're seeing in the mech, in the VR is actual motion, which takes out some of that self-conscious behavior as well. So I think Sam's very, very right. We're wired to do what's efficient. We're also embarrassed. And so I think I saw some data that 70% of stroke patients could fully recover limbs if they would get over the fact that they just typically won't use them.
Yeah, I was
Wow.
gonna ask about, because I've worked with kids who also had brain injuries that we did do like intensive like constraint therapy with, and they would put like a little like tiger mitten, like, but that was like strapped down, but they had the hand that they really wanted to move was like a mitten that they preferred, or a hand that they preferred, and you would play. But the fact that they were so open, they weren't embarrassed about playing with their new super, like either superhero hand or a tiger
Yeah.
hand. Like
Mhm.
they wanted to
Whatever their
try
favorite
everything.
animal, or yeah,
Yeah,
exactly.
and it's
Yeah.
hard to do with adults to be
Well,
like,
I was just going to say, like within music therapy, when I worked with rehabilitation, it's a lot of the same principles, right? But we're using music as that motivator, which is very similar to the game. What you're talking about, Ryan. Just instead of a mech, we would actually just be playing the drums, and so we'd be progressively working on getting more range of motion through that arm, and working on left side neglect, and trying to get the patient to utilize more of the left side
yeah, the whole
vision. And
clock.
so there's and so we would start with doing a drum roll down, and then slowly through that motivation of music and through that immersive experience, you're gaining that neuroplasticity to regain some of that motion and movement. It's not happening in an hour, but it's
Yeah.
happening over time. And it's really amazing what adding that media to that therapy can do to enchant somebody to go all out and put more effort into maximizing the outcome there. That's amazing. I love it. I love how much parallels there are across all these different disciplines. And once we all come together and start maximizing the potential, it's really, really amazing.
Yeah,
Well, I
especially when
think,
you
Yeah.
think about rhythmic movement and
Hmm.
music.
Oh yeah.
yeah,
Well,
one of
even
the
when you're
things,
talking about having the things on their hands, it's like that's the immersion we're talking about. It's not digital immersion, but it is immersive. It's easier for kids or for younger people to picture themselves in those spaces. Yeah, it's just a glove on my hand, but they're thinking, okay, they're clawing at something. They're
Yes,
like,
there's a whole
like
imaginary
Hulk
experience.
fist, like they're like it's
Yes.
not just something, an accessory on their hand. It's more than that. So
Hmm.
really getting people to believe in that immersion, that's where you're going to see a lot of
Especially in
the
VR.
positivity come out. Oh yeah.
Yeah.
yeah, I think if we really think about this too, one of the things that's such a unique opportunity around sort of this concept of immersive medicine and putting people into these different spaces, whether it's in VR and in other ways, is to be able to leverage these different brain pathways. We know that engagement and attention is really key, right? If the brain or the person isn't focused in a particular way and engaging in these activities, they
Mm-hmm.
oftentimes they don't work. And so this
Hmm.
example we've been going through, like with somebody who has a stroke, if they're in the early phase and they can't move, yeah, there's the issue of like embarrassment, or they get frustrated because they can't accomplish the task. But if you put them into an environment where they are paying attention, it's fun and engaging, they like want to do it, and you create
Hmm.
opportunity for success with whatever activity, then you've really changed the paradigm of how we think about rehabilitation, what opportunities are there. It's not just getting out of bed and moving. You can activate a lot of the same brain pathways, neural pathways, just by imagining movement versus
Hmm.
actually executing it. And so there's really compelling opportunities to really rethink the way that we do some traditional, modes of rehabilitation, using this as an
Let's
example.
back you up
Yeah.
for just one second.
Yeah.
So
Yeah.
this, guys, I've brought to you guys before, and I learned it from Sam. This is the
Hmm.
idea that for the brain, simulation and reality are the same things when we're talking about putting these neural pathways back together. Maybe you could talk a little bit more. Well, this is some of your core work that you did, right?
Yeah, this dates back, I'm dating myself, but like, even decades now, like
He's
when I,
very old.
yeah, the hair used to be brown, but these concepts have been around for a long time of understanding that mental rehearsal is actually, very valuable and leverages and
Mm.
engages a lot of these pathways. And so, this is going back a long time ago, but if you look at elite athletes as an example, like you'll see a gymnast, for example, they will
Hmm.
Mhm.
sit before the Olympics and they have their tumbling routine, for example, and they will sit and they will visualize every step of that routine. Like, what does it feel like? And it's very important, it comes from a first person perspective. So we know if you're like looking in a mirror at somebody doing something, it doesn't work. If it's the perspective of you looking out into the world and you're meaning to understand, like, where are your limbs in space, how are you moving, how are you engaging with the environment, the brain interprets that as if you're actually doing those things, right? So
Wow.
we can take advantage of that just like these athletes do, where they're doing mental rehearsal. The reason they do that is there's muscle memory and how the brain interprets each step or each motion. You can feel that sort of in your mind, if you will, right? And so we can leverage a lot of these core principles as we start to engage with patients across a variety of different, things that we want to treat. And so it's super powerful. It's very well proven, but we haven't had a great mechanism to be able to do this, right, until even more recently. And so this idea of being in a headset and creating these experiences where the patients can engage and do specific things that we know will lead to a particular outcome is just super, super powerful.
So if you're designing, this is a really important conversation, and one that Jeffrey Sang and I have all the time. There always is a game somewhere. There always is a narrative somewhere. The question is,
Yeah.
we all know the game is played in your head, and the narrative is contemplated within your own mind and within your own head. But sometimes that's where the game is constructed as well. If you look at something like Beat Saber, they're well made. There's
Mhm.
a narrative there, but you're crafting it, right? Why
Yeah.
are you doing this? And the more that you are pulled into that story, well, you're given this agency and control, the decision to be able to do the things you want to do. And then we're microdosing you dopaminergically, but not to transact financially, but instead to transact through the challenge condition. Oh, you did good, you did good, you didn't do so good. Oh, you're doing good again. And if we can just keep you in that place where folks can feel that they're generally accomplishing and the work they're doing
A
matters,
state of
and they're
flow.
that's right. Now you're flowing
Mhm.
and you're feeling flow plus accomplishment. You can hold flow for a while without accomplishment, but when you pair that up, that's that the Mario magic, right? That's why we need folks that
Yeah,
really
that's
know
sweet
what
Yeah.
they're
spot.
doing here, because at that point you become highly suggestible. You start making new neural pathways, and some of the literature is suggesting it as much as 40 times the rate, right? So
Wow.
this is where we're kind of hacking that. We'll call it the guru gene, right? And so if you think about even the early place that we've started with a breath mechanic, it's like, well, why do I need to do this in a dopaminergic state? Why do I need to do this in flow? Well, you can go sit on a mountain for 20 years like a monk, and you will become. And we see this monks that have been doing this for 20 years. If you take a look at where they're at in their meditative state, you look at their brainwaves, they are unlike anybody else's brainwaves. So
Hmm.
Mm.
it's 20 years on the mountain, or potentially what we're talking about right now is learning this during a interactive gaming play environment where you're much more suggestible. Because our cognitive brain is not wired well to our subconscious brain. We're not set up to teach ourselves a whole bunch of things, specifically those things that autonomically function throughout us. And we see that whenever we talk about and learn a new sport, or if you are out there and you're playing some tennis and you're having a great time, and I say tennis because that's what I've been learning to play and I really enjoy, it's always great until it's lesson time. Now, if someone tells
Hmm.
you 10 things that's wrong with your swing typically gets worse, not better, while you try to navigate through, cognitive self-telling, smooth muscles and all these various things, what to do, and skeletal muscle, how to move in a way that it's supposed to be reactionary, right? It's supposed to be kind of before you think about it. So, yeah.
It's interesting. I have a colleague who's at NYU, and during epilepsy procedures, we'll often put little electrodes into the brain for a week or sometimes even longer than that. And he started to look at, could he teach principles of meditation and like what is their brain activity look like? And
Yeah.
you can actually go through and, using different mechanics, start to train to this. So there's becoming these proof points where we know that this external stimuli or engagement or teaching, that we can actually track real effects and sort of what the EEG patterns of the brain are, and sort of how they change and morph in the direction of, like, what stimuli we're providing or what teaching is happening. So it's very real. Like, we can take these things and teach people to do it, and we see the brain respond. And so we're getting much more sophisticated at understanding this, which again allows us then to kind of create on the front end these opportunities to create these therapeutics and treatment opportunities with immersive medicine. It's pretty neat.
Amazing. That's fantastic. I know we've got a bunch of questions here. I'm just seeing who's wanting to take it. Kira, do you
Can
want
we
to
get
go?
into the wearable? Because I want to hear about the Q collar. I feel like the people need to know.
Yes.
So tell me your question then.
Oh, I wasn't sure if we were going to go on to a different one. Okay. So, I have some experience with AR and VR. We just finished teaching a summer program about it. And one thing that really interested me was I was thinking about different wearable technologies to have for like youth for different safety reasons, different health reasons, first aid reasons, having allergies, something like a keychain they could have where you can scan it, for example, with AR. So when I heard about your work with the Q collar, I was very intrigued. Hopefully, you can tell the audience a little bit more about what the Q collar is, as well as how you think these wearable technologies are going to evolve in terms of helping to prevent or treat neurological conditions.
So you're talking about the Q collar for concussion. Is that what you're referring to?
Yes.
Okay. Yeah, so just full disclosure, that was not one of the things that I worked on, but very involved in the concussion space, concussion prevention space. So the Q collar, for those who aren't aware, is a collar that goes around an athlete's neck and provides some very slight pressure on the jugular veins. And at least the conceptual idea is that decreases a little bit of the venous return from the brain. So the brain gets about 20% of cardiac output. So a lot of blood goes in, a lot of needs to go out. And the idea is that in a concussion, you get hit and your brain sloshes around. So the
Yeah.
Mm.
idea is, if you create a little bit of back pressure, it creates a bit more turgor and it's less likely to move around. So that device is not a sensing device, it's a physical device to try and do that. Um, that's a complicated question with the Q collar. Just to kind of talk about it for 2 seconds. I think that there's been some reasonable data around that. I'm not a huge fan, because that type of technology, and one of the things that's, I think, important just for this conversation about any technology, is the usability of it, and the fact that
Hmm.
somebody can reliably use it. So the problem with that is it needs to be in a particular location. If it moves,
Right.
then it's not going to have the intended benefit. It can be too tight, which could be dangerous, could be too loose, it's not effective. So it's an interesting idea. I'm not like a huge fan of that, but sort of as a general concept of what you're talking about, I think instrumented players, the idea of getting data and other things like that around youth athletics is really compelling. And so as we start to instrument players, we start to instrument, equipment such as helmets, then we start to be able to leverage this like evolving world of technology and data to better understand disease. And I think this is a big part of what Ryan and I are super interested in, is not only can you start to provide stimulus, but then we start to, be able to use wearables and other technologies to start to
Yeah.
understand causal relationships that are out there. And so the sports analogy for me
Mm.
is a good one, because we want to know, like in the concussion, just as an example that you brought up, what are the players doing? Where are they positioned? What is their, physiologic state? And then something happens, right? They get hit. Where did they get hit? What are the rotational forces in that moment? Because, like, we know from, like, I did a lot of stuff with the NFL. We know that there's some players that'll get hit with like 120 Gs, like more than you would get as like a
Mm-hmm.
fighter
Wow.
pilot in a role. And those guys just boom, they bounce right back up and they're perfect. Whereas somebody can get a like more of a tangential blow and they'll have a rotational force that's much lower Gs, but they're very significantly concussed. So we're still trying to learn and understand that, right? And so data becomes a really compelling piece of how we're looking at, individuals as patients and starting to really, bring an intersection of these things together. So, for example, we go back to the other thing we're talking about. So we put a patient in a headset who has a stroke. Now we have the opportunity to start to monitor a variety of different output functions, right? Maybe we're recording EEG, maybe we're recording pupillary responses. We're looking at
Mm-hmm.
muscle tone, a variety of different things, right? So now all of a sudden we can start to take that data and use it to craft maybe even dynamically what we're presenting back to that patient so we can accelerate the curve because everybody's different, right? And
Mm-hmm.
Right.
always, even though they're kind of bunched together, they're always unique, right?
Yep.
So now we can start to understand what's the input function, what do we see, and then how do we maybe dynamically change that media in the moment to get faster to the endpoint that we want. So I'm kind of like taking your question and turning it a little bit, but like that's the kind of
No,
stuff that is
I like that.
really cool.
I think it's really cool to bring up I mean, when we're talking about different technologies, when it's digital, it's just, do you have access? Do you have, like, can you utilize these technologies just on a digital front?
Well,
Mm-hmm.
Kiki,
But when
we
we're
also
talking
have
about wearable,
knowledge, right? We have input
sorry?
output knowledge. We have knowledge, which is really cool. Like if we're going to show you a piece of media and you're playing a game, at the same time we have a sensor on the
Mm-hmm.
brain. Now we have an
Right.
extrinsic stim, and we know that we have given you. We know if we've hit you with a jump scare. We know if we've put you in a stressful situation, and we start to see things from an input output perspective that we can put into a machine learning environment that's going to teach us things that there's no way we're going to know by ourselves. And it's such
What
pure data. It's not been intersected in the middle of interpretation by a physician or the individual themselves. It's like we purely know right now have just ingested this piece of media that's asked you to think and do like this, and as a net result of that, your brain has just done this, and that's going to become a really powerful diagnostic and eventually a very powerful therapeutic.
I want to just touch upon like the differences of how brain injuries and like also concussions, the impact force, even torsion can affect how much someone is like, can affect how much they're concussed, and whether they bounce back or not. But I also want to touch upon the fact that imagine, like, how we work with so prisms, if for anyone doesn't know, if someone has a brain injury and they might have like their plane of existence is like skewed, we use prisms to kind of like practice teaching their brain that no, this is actually the right way, or versus vice versa. It's so awesome to think about what we can do in VR and actively get feedback to having that
Mm-hmm.
person, get that plane, that visual plane to where it's normally is, and then having them practice all these different like experiences, or even playing a game that they're getting to that flow state to help with, shifting that, that visual plane. I love that concept.
I think as a therapist, the idea that you can start, if you will, altering reality for the moment, for the thing that
Mm-hmm.
you need is really key. And if you're looking to design these sorts of things, it's really important to listen to what Sam's saying, what Toby's talking about requiring and stuff like that, because these are things that could greatly accelerate the therapeutic process if the therapists have the right dials in their hands, right? If they have the right stuff that's available to them. And this is why we talk a lot about, moving much more towards dynamic interactive experience versus empathy based games and stuff like that. Like, it's important to know what it feels like to be somebody
Yeah.
who's has a mental impairment, but that's not necessarily going to help you treat them. And so
Yeah.
these
I
games
Mm-hmm.
we're talking about here are really about how we get you deeply engaged in flow, deeply engaged in play and narrative, and then start looking at these core concepts of simulation to reality, doing the kind of things Toby's talking about. It's like, okay, I'm gonna want to tilt you here. I'm gonna want to move you like this and do things that otherwise practically in a therapeutic setting just isn't possible. Like you're not going to be tilting the hospital 15 degrees.
Yeah.
Yeah,
Yeah.
that's fair. I mean, it's interesting. I mean, I do want to touch on the fact that a lot of the things that we've mentioned and talked about with Sam today are focus more on physical health than mental health specifically, which is really unique. And I think that's something that we should keep in our listeners' minds as well. Is typically we're talking about how mental health and digital therapeutics can go hand in hand, but there's a lot of outcomes that we can have with digital therapeutics and immersive medicine in the physical health space as well. And I love what you're saying about this dynamic response to in therapy. And it just makes me think again about music therapy, of working in the moment and changing and recreating an experience, or evolving the music in the moment to respond to a client. There's a whole approach to music therapy that is just based on creating music to respond on your client or your patient's movements, and to mimic that, and so that way they learn a sense of agency through those, and literally dynamically changing the experience for them to create a therapeutic experience, which is it's amazing. So we're moving in that direction to where we will become more automated, right? Where we will have a therapist or a physician who's implementing this and tailoring it, but a lot of it is really going to be based on the individual inputs and outputs, like you're saying, Ryan, based on data for that individual patient or that client or that situation of that's going on.
Absolutely. And kind of pulling that back to mental health, the simulations, guys, for everything that we know at the moment, the simulations are just, if not even more powerful when we talk about mental health. Because it's one thing to simulate something that physically that's difficult. We can do that in environments. We can do that with treadmills that, pivot stuff like that. But where else can we simulate success where there's otherwise failure in the real world? Where else can we
Yeah.
put you in a place where you can take agency and control over a situation that if we put you in it in real life, like if you've had car accident problems or things like that, we're not putting you back in a car, getting you back in an accident and giving you a sense of control. And this time your behavior is such that you reconsolidate memory in a happier, healthier way, right? So these simulations are really, really key. And I think that's why we see a lot of vets, I mean, being involved with, Call of Duty and stuff like that. Sam and I are on our way. We're gonna go be with Dave Anthony right after we're with you guys.
Oh wow, that's exciting.
Yeah,
Speaking of Call of Duty.
Yeah.
well, exactly. So he was the director and creator of Black Ops, and a lot of people were on his case for a long time about building something that was necessarily not particularly great for society. And what we're learning today is really how much he gave people the ability to get back into situations like if you were a soldier and then regain agency and control over that environment that you had been in before and reconsolidate your memories in a way that you had a lot more comfort and confidence and maybe start seeing a different situation as opposed to having high anxiety, a post traumatic stress disorder kind of situation. So
Yeah.
there's a lot that we can do here with, and simulation is just so powerful.
100%.
What advice
Um,
could you give? Oh,
oh, sorry. I'm just mindful of time. I
oh
think we have
yeah.
about 5 minutes left with them. So
Okay, no worries.
I was going to just combine. I have two questions, but I'm going to combine them into one, and I think it'll kind of transition us nicely into some outros. So Sam and I guess Ryan as well. I'm curious to know, as two people heavily involved in medical innovations and in the market, what are some of the biggest hurdles you guys find in terms of implementing some of these technologies in healthcare? And then looking forward, what are some promising technologies that you kind of see they're now existing, and how will those be implemented in the future? So challenges, and then what is looking good outside of those challenges?
Yeah, I'm happy to start. So, I think anytime we make something new that's novel or revolutionary in some way, it's, talking about adoption, right? And getting people
Yeah.
knowledgeable about what we're doing and what the opportunity is and sort of, what we think the therapeutic, benefits are. And so medicine
Hmm.
tends to move a little slow, as I think we're all aware. And a big mission for Ryan and myself is to get out there and start to educate people. Like, we're in a really unique moment in history and time that these technologies have come to a point where we can do things that we just never thought were possible before, right? Like, you can, to this conversation, like, you can take immersive medicine, put somebody in a headset, take them into a totally different world, start to work with them in ways that were just never even possible, like even a couple of years ago, right? So, like,
Yeah.
the world and the intersection of technology and healthcare is at a point that is so incredibly exciting. It's really complicated on some level for people to understand it, and so a big piece of our mission is not just to build these technologies, but to educate people and make them realize that there's this amazing world that's happening, and it's going at incredible speed and pace. And so just as Ryan was saying, not only can we present media, we can present, therapies, but now we have a totally unique way of starting to understand them with all of these, very high end tools, whether it's functional imaging or, EEG or, this
Hmm.
emerging world of brain computer interface that we're, you know, very, very involved and interested in. You're kind of starting to look at both ends of it in really novel and unique ways. And so we want the medical world, and that's a big, piece of my mission, is to make people aware, both on the patient side, but really importantly for me, on the clinician side, that these tools are being developed and that they need to
Yeah.
integrate these into their practice to really, if they're going to take advantage of the moment, to benefit their patients.
For me, there is a giant irony at the moment. We talk about this all the time. We have a mental health emergency, and the thing that's going to solve it is media. But where we've started is we've created a mental health emergency, and part of what created it was media, if not in its entirety. And so now we have to get out there and do some really, really hard work very, very quickly. This is conversations we were just having with the World Health Organization. We got to talk about media and nutrition, and we got to do it now because there's a
Hmm.
lot of power here that we can wield. But if we get dogmatically locked down in these places of, oh, first person shooter bad, no, that's going to be okay in this case. We're going to use that as a therapeutic. Oh, this game over here good, or let's go do some quality TikTok time. Highly dopaminergic to the point of addictive, very, very quickly. What are we going to do about that? Like, what is, and so if we don't understand, we can't wield the media appropriately. And so I think the greatest barrier right now is getting the docs to understand that, and even with these new reimbursement codes coming on, how are we going to hook the docs up? How are we going to get Medicare and Medicaid paying the way they want to? They're setting these up for a reason, and get folks to understand that there is a differential, and it's not, oh, well, this person was doing this thing in the game and therefore that's a problem. It's more about, all right, can we separate what happens when predatory work, it happens with the free and unmoderated chat, with the monetization schedules, and pretty much it's always follow the money kind of stuff. It's
Hmm.
making you undue amounts of cash while you're delving in misinformation or overexposure of vulnerable populations. We got a media problem. When you start to control those things, you end up on the other side of the spectrum very quickly with something very powerful and effective. So getting people to understand that, they ever nuanced conversations, especially when one has been so heavily polarized already to video games bad, and first person shooters are the reason Columbine happened, and all of these various things that we're seeing. Johnny's in the basement 10 hours a day, there must be something wrong with Johnny, and maybe there is, or maybe Johnny has found a perfect accommodation at that moment in a period of time, and it's going to take us a nuanced amount of information to interpret it. I think what else is really tricky there, and I'll wrap up on this one, is it's not just that it's a difficult conversation to have. It's not the same for everybody, and
Yeah.
we're all overwhelmed already. Like, as parents, don't tell me there's 5 more things I need to know about my kids being in gaming, because I already can't keep up with all the stuff that's happening. So we
Right.
really do need tools and stuff like that to get folks in the right place.
I'm
Yeah.
going to end
Yeah.
us with this. It's so cool to think about this idea that media can be used to help people, right?
Yeah.
It's so antithetical to the way the medical system's been set up, right? And so, like, the opportunity here is huge and it's very real. There's great substantiation for these things. It just hasn't been at the forefront of the way I think certainly like physicians and other healthcare providers think. And so it's a fun moment to be bringing this forward to their attention and working on this, because we think it can impact, millions, if not billions of people in a way that as a clinician, we can never reach, support, folks in that way. So the opportunity is just, super amazing at this point. So it's a fun thing to be partnered with Ryan working on this.
And all you guys do. We got to run. We're a minute late for the next thing we got to go do. But thank you guys so much. Love
Yeah.
seeing
Thank
you every
you.
week.
It was a pleasure to have you, Ryan, and Sam. Thank you so much for your time and your perspective on what's happening in this really unique and exciting space. So thank you,
Yes.
guys.
All right.
Get on with the rest of your days. We'll wrap it up here. But yeah, we really appreciate your time and thank you so much.
Thank you.
Be safe.
Bye.
Awesome. Very cool. Man, what an awesome guest, right, guys?
Yeah,
Yeah.
amazing. I'm so
Wow.
glad.
Yeah, I mean,
Gotta
like,
pick their brains.
yeah, I feel like there's just so much. Again, I always say there's just so much potential, so much to talk about. One thing that I was thinking about as Ryan and Sam were just about to leave is just, the intention behind media. I think that's one of the biggest things, right? Because what Ryan's saying about, shooters not being bad for you, or they can be therapeutic in ways, it's using them intentionally to get those desired outcomes. And right now, the way a lot of games are created is to intentionally make money, right, for producers. And so, um, changing and shifting that intention behind the media from the get-go, from the initial stages of planning and conception, will hopefully start to see some really amazing potential out there.
And I think also, like, in terms of the FDA clearance and stuff that's going on with Deepwell, it kind of, in a way, will kind of promote accountability.
Hmm. Yeah.
So I'm like really excited about the future once this becomes like more mainstream, and especially when we talk about reimbursement too. So it's in a
Yeah,
way the reimbursement will drive the accountability in some way. So I'm excited.
it is exciting. Kiki, take it away. Anything that's going on in your I don't know, thought maker, any big thoughts? I know you've got a lot always going on up there.
I mean, I'm always here for the conversation. I wish we got to pick his brain a little bit longer. I know there
Yeah.
were a couple other topics we wanted to get into, but I think he dropped some really good points and left a lot for us to check up on.
Amazing. Awesome. All right, guys. Well, this has been awesome. It's always nice having you guys with us. It's
Mhm.
always fun doing this, and really excited to continue making this and sharing this information with our listeners out there. Kiki, do you want to take away for our little outro for
Yeah,
today?
thanks everybody for listening. Thank you for tuning in again. Another one under the belt. We love to see it. Remember to check out our website at immersivemedicine.org, and also
Hmm.
feel free to connect with us on LinkedIn on our Immersive Medicine Network page. But yeah, thank you so much for tuning in. We will see you guys next time.
Yeah, and if anyone wants to reach out to us, feel free. We'd love to hear some topics that you'd like us to cover, or if you have questions
100%.
that you'd like to ask Ryan or any of us, feel free to reach out to us, and we'll be happy to try to get you involved in the conversation. Awesome, very cool. Thanks, everyone.
Thanks.
Bye.
Bye.